This is DevOps in Agile Way podcast.
Hello everybody, welcome to the 8th episode of my podcast. This time we will discuss two elements of serverless which are very important to remember and to understand. I will base on AWS Lambda, of course, as AWS community builder, but this works in a very similar way for other vendors as well. I mentioned in the first episode that I'm a big fan of serverless, but I also try to be objective and understand not only the positive side of the solutions, but also the negative side of it. I believe this is quite critical to do so if we want to be seen as impartial and professional in our area. So, this time we'll talk about Coldstart and cost effectiveness of Lambda functions. I gave the example of potential billing in my first episode, right? This time, however, I'll not do it. Not because it is not important, but because the pricings are different between vendors and what more, it can change in time. And also, we need to remember that AWS Lambda is not only one element of serverless ecosystem. Let's start with first things, Coldstart. Well, honestly speaking, I'm sure that let's say fanboys will tell Coldstart is not a problem at all. However, haters will shout Coldstart is no-go for serverless. And you know what? Both are wrong, really. Coldstart might have impact on your application, but if you are aware of it, you can deal with it. And, well, to some extent, at least, of course, right? I can agree that we have the tendency to overrate the problem with Coldstart. Alan Helton asked once on Twitter if anyone experienced issue with Coldstart on production, and he said that the most of the answers were no. However, I would be in the yes camp here. I will come to this a little bit later when I explain what Coldstart is. So what is that phenomenon? In simple terms, this is the time which is needed to start the application. I know it sounds a little bit vague, so let me say this in a little bit different way. Serverless is a pay-as-you-go model, right? It means that all resources are started only when needed and only when called, correct? So when we call the resource, it needs time to start. In other words, to go from cold state, resource doesn't exist yet, to, well, warm state. Resource is ready and can process our request. So it lengthens up the latency of the full execution of the request. We can identify two types of cold starts. We have impact on both, but one is related to vendor and second to our actions. We can say that. So first one, the vendor related. This is the delay during which vendor is preparing the infrastructure and the system. We need to understand that two elements are very important here, runtime and size of the package. How it looks? Well, in general, this is the process. We send the request. It is the first request in some time, so we don't have any resource in warm state, right? Our vendor needs to initialize some resources then. In case of AWS and Lambda, Firecracker Micro VM are used, right? At least this is what I know. This is the technology developed by AWS to run very small, lightweight, and fast virtual machines. And those virtual machines are hosting containers and functions. It is based on Linux kernel, of course. So when we send the request, the micro VM needs to start. Simple. And guess what? It takes time. Now, the runtime comes into the picture. Depends on what runtime we choose. In other words, what is the language we use, right? So it can be Node.js, Python, .NET, Golang, Java. This micro VM needs to prepare everything around to run or execute this specific runtime. Now, from historical standpoint, it might be important. Yes, AWS did a lot of work to make things better now, but some time ago, Java or .NET were much slower than Node.js or Python. These days, it is better and better, but I will still risk to say even if those times are quite comparable now. However, compiled runtimes are slower in terms of cold start and to bring everything up. Second important element here is the size of the package with our code. During this initialization activity, the code is downloaded from the S3 bucket, unpacked and prepared, right? And obviously, network connections are very effective nowadays. Unpacking itself is quick too, but in space of millisecond, it is quite important. If the code package is small, like let's say 128 kilos, or big like 10 megs. In this case, we also need to understand the behavior related to libraries or modules we use. How we implement them, do we keep them with the code or in the layer, and so on. And obviously, more libraries we add, longer is the time of the initialization. Even if we don't use any element of the implemented module, we need to initialize them. Right. This was the first type of cold start. Second is somehow in our control. It is caused by, let's say, things in our code and how we code them. I am not a developer. Please take this into the consideration, but I believe I am able to explain it quite reasonably and quite well. For those of you who are not familiar with Lambda function, let me explain on the Python code example, okay? The main place of the Lambda is function called handler. This is the place where Lambda will start its execution. Of course, we can have much more functions inside the code. Let's call it sub-functions in our case here, right? But this is common in any program language. But often we have something in the code what is outside any function. For example, in case of Python, imports, setting for specific modules, and so on, and so on. And so, of course, it's not only for Python, but this is the example. Sometimes even more heavier operation than that, like connection to databases, collecting secrets, clearing the cache, so on, so on. Another element which impacts performance is related to infrastructure. All design decisions might impact the performance and make the cold start longer. If your Lambda is in VPC or not, does it connect to Dynamo, Secret Manager, Elasticsearch, or whatever else? If yes, and probably it is exactly what is happening, your Lambda initialized longer. Some time ago, I tested it, and connection to Secret Manager and Elasticsearch from cold Lambda written in .NET extremely changed the latency and user experience. And it was really observed by users, right? And pushed back to us with the feedbacks. All of this has impact on the runtime. Again, more stuff here means that more time is needed to start the actual processing of your request. Now, let's come back to the argument, it is a problem or not. Well, it depends. As usual, this is the best answer from DevOps. It depends, right? It depends on what is your business case and how you use serverless. In general, we have two options, right? We can have synchronous or asynchronous execution. I learned that this concept is sometimes hard to grasp for people, so let me use here some analogy. Even crazy analogy, and I hope you will find fun in it. So you read a book. You read it, and at the same time, while reading, the content is entering, if I can say so, into your brain and imagination, right? So you read words and you imagine this. In this case, it will be synchronous execution. So you cannot postpone collecting the letters in your mind for later when you're reading it, right? However, if we think about asynchronous option for reading, I know how it sounds. Someone is reading the book and records as audiobook. Sometime later, when you have time, you just listen to the audiobook and imagine the content. So the reading is like a splitted from the imagination of the, let's say target person, right? So those two actions here are splitted. And this is exactly how synchronous and asynchronous approach works. So in synchronous communication, the client sends the request and waits for the response. The request must be proceeded quickly and response returned to the client back in the shortest possible time. In asynchronous communication, the client sends the request and doesn't really wait for the response. Request can be proceeded when application has time or capacity to do it, and then returns response in some way. It doesn't matter which way, but in some way, let's say. Now, if we use asynchronous pattern in communication for our application, the cold start doesn't sound as a big problem. The architecture contains some queues, message buses, and so on, and the design itself is prepared for, well, let's call it delays, okay? The architecture is designed with principle that response is asynchronous and request is proceeded when system is able to do so. Before that, the request is kept in some wait state, okay? Where cold start might have impact, really, is synchronous communication. Not always, of course. However, there are cases where it might be even crucial and critical and even, let's say, no-go for serverless. I don't know how many of you used a Cloud Guru. This is an online service which provides training mainly for clouds. I used it for the first time, I think like 5 years ago or so. And a Cloud Guru was built already in serverless. And you know what? Those days, the cold start was more problematic than today. And if you knew where to look, what to look for, if you knew how serverless behaves, you were able to clearly catch the moment where cold start impacted the web page. Why had it happened? And why it might still happen? In fact, it still works this way, really? Well, serverless is used for backend part of the application, right? If we consider the fully serverless web application, the classic approach here is quite simple. We have the frontend part, the website itself, for example, stored in S3 and hosted through the CloudFront, which is the CDN, right? Content Delivery Network. And the frontend communicate through the API gateway behind, which have the serverless functions connected from the, opposite side. So API here is in the middle. Now, if you click the button or link on the web page, you expect to have response very quickly, right? We all are annoyed when we need to wait for the web page to load, right? Right? I think so. So I remember the times in the internet where really I was waiting for 3 or 4 hours to download video clip, and if I remember correctly, it has like half of meg or even less, right? It was more than 20 years ago. But today we expect it will be like a blast. We click the link, pick, done. Now we test our backend Lambda function, and we know that warm Lambda responds in 150 milliseconds, and that is perfectly fine for us. But then when cold start happen, it may be 2.5 seconds. You may say, oh, come on, what is 2.5 seconds? Probably you will be right. But 5 seconds, 10 seconds, this is quite a personal perception, and we cannot allow to cloud the judgment of the behavior of the application by our own approach, because for us 2.5 seconds is okay. We should, simply speaking, ask our customers. In this case, this is quite important to understand how cold start impacts our application and to understand how we can improve and shorten the time of this cold start. So, to conclude this episode, I have to say this. The approach to architecture of your service or application must be done properly. It needs to meet business needs, right? And I know it sounds funny, but this is why we have architecture. Is serverless bad or problematic? Oh, hell no. Of course not. It is an amazing way of creating things. But sometimes it might bring some problems to the table, and we need to be aware of the downsides of the solution. And that's it. There is no magic behind. So, that's all for today. I know that I said on the beginning there are two issues to be mentioned. The second one, the cost optimizations or something like that, will be mentioned in the special episode. We discussed some downside of the serverless today, right? I will create the episode also about the positives of the serverless and what kind of opportunities we can rise even with serverless approach. So stay tuned and till the next time.
Thank you for listening to this episode of DevOps in Agile Way podcast with your host, Pavel Pivosh. Subscribe, comment, and do not forget to check our next episodes. Stay tuned. Stay safe. Stay curious.